Hi students, in last video we discussed about optical fiber gunshot bits, that is we are expecting questions. Now in this video we are discussing the second part in modern physics, that is photoelectric effect. From this topic also every year one question is coming. So the question is coming in photoelectric effect from 4 different topics. The question may be asked from photo emission, that may be related to photoelectric effect or photoelectric current, and mainly important, that is Einstein photoelectric effect and small definitions related formulas in work function and threshold frequency. So before starting, just 2-3 minutes I will explain this theory part, then the student will understand easy questions. So here also questions are asking 3 types. One is definition based question, that is concept oriented question. What is work function, what is threshold frequency, what is photo emission, what is photoelectric effect, like that. Then you will ask formula based question, how energy is directly proportional, how energy is proportional to frequency of light, how energy is related to wavelength of light, like that is asking formula based question. And the third type is numerical based questions. So here the basic concept, see here students, I am considering a metal. What is this? This is a metal. We know that all metals are good conductors. So good conductors consist of what? Free electrons. So when light is incident, on this metal surface, this is light, I am considering F, sometimes mu also, but very important, here we are considering mu only. Here when light is incident on the metal surface, then the electrons will be emitted from this, metal surface. So when light is incident on a metal surface, then the electrons will be emitted from the metal surface. This phenomena is known as photo emission. So here Planck scientist, according to his quantum theory, he given some characteristics of light. So light is a stream of particles. That stream of particles consist known as photons or quanta. Photons consist energy E. So this photon energy E, I am representing E, is directly proportional to frequency of incident light. Very, very important concept. Energy is directly proportional to frequency of incident light. From that E equals to h mu. E equal to what? H mu. This is the first formula, very, very important in solving numerical questions. What is E? Energy of incident light, energy of photon is equals to h mu. What is h? Planck's constant. Mu is frequency of incident light. Then frequency C equal to, we know that mu lambda, from that mu equals to C by lambda. Then in terms of, I am writing wavelength, in terms of wavelength E equals to hc by lambda. So here the maximum questions are related to from these 2 formulas only. Energy of photon is directly proportional to frequency of incident light, and energy of photon is inversely proportional to wavelength. Some application we are considering energy units joules, in some application we are considering energy units as electron volts. You must remember the relation between electron volts and joules is 1 electron volt is equals to 1.6 into 10 power minus 19 joules. So this is the basic requirement, this is the basic fundamental is required to understand these 4 topics. Students, remember the concept, energy of photon is directly proportional to frequency of incident light and energy of photon is inversely proportional to wavelength of light. ఇక్కడ కాన్స్టెంట్స్ వచ్చేసి 2 కాన్స్టెంట్స్, h Planck's constant that equals to 6.625 into 10 power minus 34 joule second and E equal to hc by lambda. Here lambda is represented in angstroms, then energy units are electron volts. Remember, now by using this concept we will solve some expected question, some repeated question in ECET. So first I am starting with the first question. See here students, first question I am reading. The threshold wavelength for a metal whose work function is W naught is lambda naught, and the threshold wavelength for a metal whose work function is W naught by 2. 4 options are given. This is previous ECET question and repeatedly they asked question. Here you remember 2 terms, very important terms, they asked this related question also. What is that one means? The first topic is work function, and the second term is threshold wavelength. One is work function, the second one is threshold wavelength. Just now I explained, when a light is incident, on a metal surface, then electrons will be emitted from this metal. That phenomena is known as photoemission, we understand. Now here what is work function means? It is the minimum amount of energy. Remember students, it is the minimum amount of energy required. It is the minimum amount of energy required to emit the electrons. Or it is the minimum amount of energy to exist photoemission effect. So that work function, remember, it is the minimum amount of energy that is represented by W. What is W means? Work function. Sometimes it is also known as threshold energy. So here the work function is directly proportional to threshold frequency mu naught. Work function is directly proportional to threshold frequency mu naught. What is threshold frequency means? It is also the minimum amount of frequency of incident light. It is the minimum amount of frequency of incident light to emit the electrons. Now here we know that frequency and wavelength are inversely proportional to each other. Then I am writing here threshold frequency is inversely proportional to threshold wavelength W naught. Work function is directly proportional to threshold frequency and threshold frequency is inversely proportional to threshold wavelength. From these two equations, W work function is inversely proportional to threshold wavelength. Here this formula is required. So students, కాన్సెప్ట్ ను అర్థం చేసుకొని ఆ అడిగిన క్వశ్చన్ కి మనం ఒక రిలేషన్షిప్ ని బిల్డ్ చేయాలి. ఎందుకంటే ఇక్కడ 2 రిలేషన్ తీసుకున్నాను. వర్క్ ఫంక్షన్ ఇస్ డైరెక్ట్లీ ప్రపోర్షనల్ టు థ్రెషోల్డ్ ఫ్రీక్వెన్సీ, అలాగే థ్రెషోల్డ్ ఫ్రీక్వెన్సీ ఇన్వర్స్లీ ప్రపోర్షనల్ టు వేవ్ లెంత్. Now from these two equations, work function is inversely proportional to threshold wavelength. Now see here, threshold wavelength is W naught when the work function is W naught. Alage is asking the threshold wavelength when work function is W naught by 2. So I am writing here W1 work function by W2 inversely proportional. That I am writing lambda 2 by lambda 1, lambda 2 by lambda 1. So what is the work function means? W1 equals to I am writing W naught and second W2 I am writing W naught by 2. That equals to, now we are finding lambda 2. What is lambda 1 is given? Lambda naught. Then what happens here? This W naught cancel, 2 goes numerator, 2 equals to lambda 2 by lambda naught. Then what is the answer? Lambda 2 equals to 2 lambda naught. This is the answer. So, in 4 options, option 4 is correct. So, when work function is decreases, then threshold wavelength will be increases, because work function is inversely proportional to what? Threshold wavelength. This is first question. Now, you remember two concepts here. What is work function? What is threshold frequency? Because some questions are asking definitions also. You remember these two formulas. Now, I am explaining second question. See students, now we are discussing second question. The threshold frequency of a metal is mu naught. Threshold frequency is given as what? Mu naught. When a light of frequency 4V naught is incident on a metal, then what is the maximum kinetic energy of emitted electrons? ఈ క్వశ్చన్ ఇలాంటి క్వశ్చన్ చాలాసార్లు రిపీట్ అయింది ఇక్కడ మనకి ఈ సెట్లో. అంటే ఈ క్వశ్చన్ ఇప్పుడు అడుగుతున్న టాపిక్ ఏంటంటే ఐన్స్టీన్ ఫోటో ఎలక్ట్రిక్ ఎఫెక్ట్ ఈక్వేషన్. వాట్ ఈజ్ ఐన్స్టీన్ ఫోటో ఎలక్ట్రిక్ ఎఫెక్ట్ మీన్స్? See here I am considering a metal. What is this? This is a metal. Now, when light is incident on the metal surface, this is light, I am considering this one. So, here I am considering E energy of photon. When light is incident on a metal surface, then what happens? Electrons will be emitted from this metal surface. Electrons will be emitted from the metal surface. If the applied incident light, is larger, then what happens? Some amount of energy is required to emit the electrons. The remaining energy, incident light energy, is given to the emitted electrons to obtain photoelectric current. So, here what is mentioned means, see here I am considering E, energy of photon, energy of incident light, is equals to, see here, some energy is required to emit the electrons. So, some energy, that energy I am considering minimum energy. So, what is minimum energy? That is work function. So, I am writing here E equals to W, that is work function, plus the remaining energy is given to emitted electrons to obtain kinetic energy. అంటే ఆ ఎమిట్ అయిన ఎలక్ట్రాన్స్ కి ఆ రిమైనింగ్ ఎనర్జీ వల్ల ఆ ఎమిట్ అయిన ఎలక్ట్రాన్స్ మూవ్ అవుతున్నాయి కాబట్టి అక్కడ ఏమంటున్నాం? kinetic energy. So, this is Einstein equation. Is energy of incident light. In that energy of incident light, some energy is required to emit the electrons. Some energy ni manam emantunnam ikkada? Work function. And the remaining energy is given to emitted electrons to obtain kinetic energy. So, what is Einstein equation? E equals to W plus Ke. Remember. Now, we are solving the question. The threshold frequency of metal is mu naught. When a light of frequency 4 mu naught is incident on a metal, then what is kinetic energy? So, here from Einstein equation, I am writing kinetic energy Ke. What is kinetic energy equals to? I am writing from the equation E minus W. E minus W. What is E? Energy of incident light. And what is W? Work function. Here, what is energy formula in terms of frequency? That is, I am writing E is directly proportional to frequency of incident light. From this, E equals to h mu. What is E equals to? H mu. What is H? Planck's constant. So, here when a light of frequency 4 mu naught, so here E equals to is given 4 mu naught into H. I am writing here 4 mu naught h, because h mu I am writing 4 mu naught h. What is that one? Light, incident light. And threshold frequency is given mu naught. Then what is work function? Work function W equals to h mu naught. Work function equals to what? H mu naught. So I am writing here h mu naught. So here h4 mu naught minus h mu naught. Then what is kinetic energy? Means 3 mu naught h. This is the answer. In 4 options, option 2 is correct. What is that one? 3 mu naught h. So ikkada manam gurtupettukovalsindi ekkuva energy, work function, kinetic energy. ఆ 3 టర్మ్స్ యూజ్ చేసుకొని మనకు ఐన్స్టీన్ చెప్పిన ఈక్వేషన్ ఎనర్జీ ఆఫ్ ఇన్సిడెంట్ లైట్ ఈజ్ ఈక్వల్స్ టు వర్క్ ఫంక్షన్ ప్లస్ కినెటిక్ ఎనర్జీ. దిస్ ఈజ్ ద ఆన్సర్. నౌ విల్ సాల్వ్ థర్డ్ క్వశ్చన్. See students, the third question is again related to Einstein equation. Choose the correct form of Einstein photoelectric equation. Einstein photoelectric equation where the symbols have their usual meanings. So just now explain what is Einstein photoelectric equation. That is E is equals to energy of incident light is equals to work function, that is W, plus kinetic energy. This is the work function formula. In work power energy, we already studied, that is kinetic energy formula. Kinetic energy is equals to what? Half mv square. Kinetic energy formula is what? Half mv square. So when I am writing Ke max, then I am writing here half mv square max. Students, now what is E? Energy of incident light. That energy of incident light equal to what? H mu. So here I am considering E equals to what? H mu. H mu and work function, here it is represented simply W naught. Simply ela cheppadanni W naught. Then from Einstein equation, this is Einstein equation, energy equals to work function plus kinetic energy. So see the first question, energy means what? H mu is equals to half mv square plus work function, correct. Second equation, that is minus, wrong. And third equation, W equals to, W means what? Work function equals to kinetic energy plus energy of incident light, that is also wrong. And fourth one, work function is equals to what? Half mv square max minus h mu, this is also wrong. So first one is only correct. H mu means what? That is E is equals to W naught plus Ke. This is the answer. Remember, very very important. సో మనం ఒక ఐన్స్టీన్ ఈక్వేషన్ చుట్టూ ప్రాబ్లమ్స్ కానీ కాన్సెప్ట్ కానీ పర్ఫెక్ట్గా నేర్చుకుంటే ఈ టాపిక్స్ అన్నీ ఫోటో ఎలక్ట్రిక్ ఎఫెక్ట్ అనేవి చాలా సింపుల్గా మనకు అర్థమవుతాయి. కాకపోతే ఇక్కడ మనకు కెనెటిక్ ఎనర్జీ అని, మూమెంటం అని, మాస్ ఆఫ్ ఫోటాన్ అని ఇలా కొన్ని క్వశ్చన్స్ని మళ్ళీ మనకు మెకానిక్స్ నుంచి కూడా కొన్ని ఫార్ములాస్ని గుర్తు చేస్తారు. కాబట్టి ఈ ఎక్స్పెక్టెడ్ క్వశ్చన్స్ని మీరు జాగ్రత్తగా ప్రాక్టీస్ చేయండి. ఎందుకంటే ఆల్మోస్ట్ క్వశ్చన్స్ అన్నీ రిపీటెడ్ క్వశ్చన్, ఎక్స్పెక్టెడ్ క్వశ్చన్స్తో చేసిన వీడియో కాబట్టి చివరి వరకు చూసి జాగ్రత్తగా వీటిని మీరు నేర్చుకుంటారని నెక్స్ట్ క్వశ్చన్కి వెళ్తున్నాను. దట్ ఈస్ వాట్? క్వశ్చన్ నెంబర్ 4. See here, the question number 4, if the maximum kinetic energy of emitted photoelectrons from a metal is given 0.9 electron volts. So students, ఇక్కడ చాలా ఇంపార్టెంట్ అంటే కెనెటిక్ ఎనర్జీని మనకు ఎంత అని చెప్పాడు? 0.9 ఎలక్ట్రాన్ వోల్ట్స్. యాక్చువల్గా మనం మెకానిక్స్లో కెనెటిక్ ఎనర్జీ యూనిట్స్ని మనం జౌల్స్ అంటాం. బట్ ఇక్కడ ఐన్స్టీన్ ఈక్వేషన్ నేర్చుకున్న తర్వాత కెనెటిక్ ఎనర్జీ ఈక్వల్స్ టు ఫార్ములా ఏమని చెప్పాను? E minus W. వాట్ ఈజ్ E? it is a energy and work function is also a minimum amount of energy. Ikkada energy and work function both are represented in electron volts. So rendu eppudaithe electron volts lo represent chesado, then kinetic energy is also represented in electron volts. కన్ఫ్యూజ్ కాకుండా మనం ప్రాక్టీస్ చేస్తున్నాం కాబట్టి గుర్తుపెట్టుకోండి, ఇక్కడ KE ఈక్వల్ టు E మైనస్ W ఫార్ములాలో వాట్ ఈస్ ద యూనిట్స్ ఆఫ్ కెనెటిక్ ఎనర్జీ అంటే ఏం చెప్పాలి? ఎలక్ట్రాన్ వోల్ట్స్. స్టూడెంట్స్ వెరీ వెరీ ఇంపార్టెంట్, ఎందుకంటే అప్పుడప్పుడు 1 ఎలక్ట్రాన్ వోల్ట్ ఈక్వల్ టు హౌ మెనీ జౌల్స్ అని కూడా అడుగుతున్నాడు. 1.6 ఇంటూ 10⁻⁻19 జౌల్స్ గుర్తుంచుకోండి. సో హీ ఈస్ గివెన్ కెనెటిక్ ఎనర్జీ వాల్యూ హౌ మచ్? Here is given kinetic energy Ke equal to 0.9 electron volts is given, and is given work function is also. What is work function is given? Work function is equals to 2.2 electron volts. Kinetic energy is given, that is 0.9 electron volts, and work function is given, that is 2.2 electron volts. Then is what asking? Is asking the wavelength of incident radiation angstroms. So student ikkada malli oka twist chesadu entante general ga wavelength units meters, but when energy represented in electron volts, then lambda wavelength must be represented in angstroms. Remember, 1 angstrom is equals to 10⁻⁸ centimeter, or that equals to in meter how much? 10⁻⁻10 meters. Very very important. ఇది కూడా ఒకసారి మనల్ని రిపీటెడ్లో అడిగారు క్వశ్చన్. 1 angstrom ఈక్వల్ టు హౌ మెనీ సెంటీమీటర్ ఆర్ ఇన్ మీటర్స్. సో ఇక్కడ లాంబ్డా ఈజ్ ఆస్కింగ్ వాట్ ఈజ్ వేవ్ లెంత్. ఫ్రమ్ ద ఈక్వేషన్ కెనెటిక్ ఎనర్జీ ఈక్వల్స్ టు ఎనర్జీ ఆఫ్ ఇన్సిడెంట్ లైట్ మైనస్ వర్క్ ఫంక్షన్. ఇక్కడ నేను ఏం రాస్తున్నానంటే ఎనర్జీ ఈజ్ ఈక్వల్స్ టు వర్క్ ఫంక్షన్ లెఫ్ట్ సైడ్ వెళ్ళిపోయింది, అప్పుడు కెనెటిక్ ఎనర్జీ ప్లస్ వర్క్ ఫంక్షన్, కెనెటిక్ ఎనర్జీ ప్లస్ వర్క్ ఫంక్షన్. సో వాట్ ఈజ్ కెనెటిక్ ఎనర్జీ ఈజ్ గివెన్ యాజ్, దట్ ఈస్ 0.9 electron volts and work function is given as 2.2 electron volts. Then what is the energy value? Here 3.21 electron volts. This is energy, but is not asking energy, he is asking what? Wavelength. What is the relation between energy of incident light, that is photon, and incident wavelength? Means here I am writing the formula, that is E is equals to 12,400 by lambda, and lambda units what? Angstroms, and energy units what? Electron volts. Energy is equals to 12,400 by lambda. Now energy is given 3.1, I am writing here 3.1 is equals to 12,400 by, we are finding what? Lambda. Now lambda equals to, I am writing 12,400 by 3.1, I am writing 31, here one more 0. So 31 4 ja 124, that equals what? Lambda equals to 4,000 angstroms. What is the lambda value here? 4,000 angstroms. And remember the relation also, 1 angstrom equals how much? 10⁻⁸ centimeter or 10⁻⁻10 meters. Now we will solve next question, that is question number 5. See students, now we are discussing 5th question. This is concept based question. The minimum energy required for a photoelectron to escape from a metal plate in a photocell is called, is given 4 option: Planck's constant, no it is a constant, work function, threshold energy, stopping voltage. Here both answers correct. Both answers correct. What is? That is work function and threshold energy. So remember students, both answers correct, but sometimes this is not expecting, we are expecting, that's why given 2 options. What is work function? It is the minimum amount of energy to required electrons emit from the metal when light is incident. Now we will discuss sixth question. See students, question number 6. The surface of a metal is illuminated with the light of 400 nanometer. So here what is the data given? 400 nanometer means what? Wavelength is given. What is wavelength value is given here? 400 nanometer. Nanometer. What is the meaning of nano? That is a 10 power minus 9. So I am writing here 400 into 10 power minus 9 meters. That is wavelength is given. The kinetic energy of the ejected photoelectrons was found to be 1.68 electron volts. So here kinetic energy value is given. What is the kinetic energy value is given here? 1.68 electron volts. Then is asking what is the work function? What is the work function? See here again this question is related to Einstein photoelectric effect equation. What is Einstein photoelectric effect equation? Means energy of incident light is equals to work function plus kinetic energy. See here. Now is asking work function. So I am writing formula work function W is equals to E minus kinetic energy. Kinetic energy is given 1.68 electron volts. Now I want energy value also in electron volts. Here wavelength is given. When wavelength is given and here data is also given, H into C equal to 1240 electron volts nanometer. So I am writing here energy is equals to 12,040 electron volts into nanometer, electron volts into nanometer by 400. I am writing. So here 0 0 cancel because nano cancel, and 4 1 ja 4 3 ja 12 and 4 1 ja 31 by 10 means how much? 3.1. What is the energy value here? 3.1 electron volts. Now is asking what? Work function. Then work function equals to what? Energy minus kinetic energy. Kinetic energy is given as how much? 1.68. So 3.1 minus 1.68. I am solving, subtracting 10 minus 8 2. Here what? 0. 0 minus 10 minus 6 what? 4. And 2 minus 1, 1. So what is the answer? 1.42 electron volts. This is the answer. So option 2 is correct. See here students, 7th question. A photon in motion has a mass. A photon in a motion has a mass is asking. Here energy of photon E equals to, I am writing what? mc square. This is also Einstein equation. E equal to what? mc square. And here in photo emission energy formula in terms of frequency what? That is h mu. E equal to what? h mu, and energy equation what? mc square. Now I am comparing these two equations, h mu by mc square. Then what is asking? Mass. So m equals to h mu by c square. This is formula based question. Here we must know two equation. One is E equal to mc square and second equation is E equal to h mu. Now compare, then is asking what? Mass equals to what? h mu by c square. Therefore option 4 is correct. Now we will discuss next question, that is 8th question. See here students, question number 8. Wavelength of 1 k electron volt, 1 kilo electron volt photon is 1.24 into 10 power minus 9 meter. Then is asking what is the frequency of 1 mega electron volt photon. Here first there is a relation between energy and frequency and energy and wavelength. So, from the data, when I am writing here E inversely proportional to lambda, E inversely proportional to lambda. So, I am writing E1 by E2, E1 by E2 is equals to lambda 2 by lambda 1, inversely proportional. Here E1 means 1 kilo electron volt, I am writing 1 into 10 power 3 electron volts, and E2 is given 1 mega, that is 10 power 6 electron volt, is equals to wavelength at the initial stage lambda 1 is given as how much? 1.24 into 10 power minus 9. Then calculate first lambda 2. Here 10 power 3 cancel, that is 10 power 3. Now I am cross multiplying, then 10 power 3 into lambda 2 is equals to 1.24 into 10 power minus 9. Then what is lambda 2 value? 1.24 into 10 power minus 12 meters. This is lambda 2, 1.24 into 10 power minus 12 meters. Now is asking what? Frequency. So, we know that C equals to mu lambda. C equal to what? Mu lambda. Then lambda 2 is given, I am finding what? Frequency. So, from the relation I am writing frequency equals to C by lambda. Frequency equal to what? C by lambda. So, I am calculating frequency in second case. So, I am writing mu 2 equal to C by lambda 2. Then what is the velocity of light in air? That is, we know that 3 into 10 power 8, 3 into 10 power 8 divided by what is lambda 2 value? 1.24 into 10 power minus 12. This one. 10 power minus 12 is in denominator. The పైకి వెళ్ళిపోతే plus 12, that is 10 power 20. So, I am writing here 3 by 124 additional గా ఇంకా 2 zeros రాశాను, that is 100 into 10 power 20. స్టూడెంట్స్ జాగ్రత్త అర్థం చేసుకోండి. minus 12 పైకి వెళ్ళిపోతే plus 12 plus 8 20, 1.24ని నేను ఏమని రాశాను? 100 by 124. Now 3 1 ja 3, 3 next how much here? Nearly 4 I am writing. So, 4 that is how much? 25. So, what is the answer means here? 2.5 approximately 2.5 into 10 power 20, that is the approximate answer. Here I am taking again 3 4 ja 3 point, that is why how much of 2.5 into 10 power 20 hertz. So, ikkada manamu energy ki wavelength relation chesham, alage energy nundi frequency kuda relation chesham. So, what is the answer? 2.4 into 10 power 20, that is the answer. Next we will discuss 9th question. See here students. The energy of a photon of a light of wavelength 450 nanometer, direct question. Here energy is asking, and here very important, here asking energy units what? Joules. Energy units what? Joules. So, actually energy E equals to 12,400 by lambda, where lambda is in angstrom. Then energy units what? Electron volts. Here you substitute lambda value 12,400 by 450 nano means how much? 10 power minus 9. So, here wavelength is given in nanometers, and if you convert this value into angstroms, Then what is the units of energy? That is in electron volts, but is asking in joules. We know that the relation between joules and electron volt, 1 electron volt equal to how much? 1.6 into 10 power minus 19 joules. So, by using these two concepts, if we simplify, we get answer how much? 4.4 into 10 power minus 19 joules. This is the answer. Here you remember whether is asking energy in electron volts or in joules. If they ask in joules, you multiply with 1.6 into 10 power minus 19. Suppose is given joules, you will ask in electron volt, then you divide it by 1.6 into 10 power minus 19. Now we will discuss next question. See here, this is 10th question. Energy of a quanta frequency 10 power 15 Hz and Planck's constant is given as 6.6 into 10 power minus 34 joule second. Then is asking what is energy? Very simple question. Here energy E equals to what? H mu, that equals to 6.6 into 10 power minus 34, that is Planck's constant is given and frequency is given how much? 10 power 15. Therefore, what is the answer means 6.6 into 34 minus 15. 14 minus 5 means how much? 9. So, into 10 power minus 19 joules. So, what is the answer here? In option 1 is correct. So, students, ఇక్కడ photoelectric effect మళ్ళీ ఫస్ట్లో చెప్పాను, అదే లాస్ట్లో కూడా చెప్తున్నాను. మనల్ని ఎక్కువగా క్వశ్చన్స్ ఫార్ములా బేస్డ్ క్వశ్చన్, న్యూమరికల్ బేస్డ్ క్వశ్చన్స్ అడుగుతున్నాడు. ఆ క్వశ్చన్స్ కూడా ఒకటే ఒక ఫార్ములా, ఐన్స్టీన్ ఫోటో ఎలక్ట్రిక్ ఎఫెక్ట్, ఆ అప్లికేషన్ నుండే తీసుకుంటున్నాడు. అంటే అక్కడ ఈ ఎనర్జీ ఆఫ్ ఇన్సిడెంట్ లైట్ ఫ్రీక్వెన్సీ పైన, వేవ్ లెంత్ పైన ఎలా డిపెండ్ అవుతుంది, వాట్ ఈజ్ వర్క్ ఫంక్షన్, హౌ ఇట్ డిపెండ్ ఆన్ థ్రెషోల్డ్ ఫ్రీక్వెన్సీ అండ్ థ్రెషోల్డ్ వేవ్ లెంత్ అండ్ వాట్ ఈజ్ ఇట్స్ కెనెటిక్ ఎనర్జీ, ఆ మూడిటితో మనము కాన్సెప్ట్, ఫార్ములా బేస్డ్ న్యూమరికల్ క్వశ్చన్ ప్రాక్టీస్ చేస్తే మనం ఈజీగా 1 క్వశ్చన్ సాల్వ్ చేస్తామని నేను ఆశిస్తున్నాను. సో స్టూడెంట్స్, నెక్స్ట్ వీడియోలో మరొక టాపిక్తో మీ ముందుకు వస్తాను. అంతవరకు ఐ విష్ యూ ఆల్ ది బెస్ట్.